Okay, welcome to the talk from the Network Inequality series, which today will be given by Viktor Stojkoski. First, I'm a postdoc researcher here at the Complexity Science Hub, part of the Network Inequality group. My name is Miroslav, so I've been colleague of Viktor for in some way, yeah, we've been working not together, but under the supervision of the same supervisor in different periods. So indirectly, we've been colleagues, but yeah, just recently we started some more actual collaboration. And Viktor has a PhD in economics and computer science, both from the university in Skopje, and above the other activities, he's also part of the group of Cesar Hidalgo, with whom he has been working for some longer period now. And I give volume to Viktor.
Thank you, Miroslav. Thanks for introducing me. First of all, thanks all of you for the wonderful week that this has been, as I'm the guest of CSH this week. Today, I will be speaking about the inequalities in the international trade of digital products, which is joint work done together with Philip Koch, Eva Kohl, and Cesar Hidalgo. So this has been a work that has been up until this month, it will be that we have been working on this for exactly 2 years. And finally, we have our first paper out on this. So I will just speak in more details about how we have arrived at our inequality studies and what are actually digital products. So first of all, I would like to start with a question, like how many of you have streamed a movie lately, or how many of you have access or have subscribed to a cloud computing service? Probably most of you have access to all of that. So essentially, all of you are participating in digital trade. So, but when you try to say, okay, when I subscribe to Netflix, where does my money go? Usually it goes to Amsterdam, as usually you're paying essentially you're participating or importing some good here to Vienna, or even the same thing when you're trying to do something like Google Cloud Computing or the cloud computing service, you're again participating in digital trade or buying digital products. But unfortunately, when we try to measure those statistics, if we try to go towards I don't know, international trade statistics data, we won't have any data on where does Netflix export or where does Google make most of their money from. So basically, we know where they make most of their money from, but we don't have a granular geographic data on where do these transactions happen actually. So, and even despite there are a lot of efforts that have been doing together by the World Trade Organization, the IMF, and even the United Nations, there is no data set which is able to harmonize international trade in digital products, and therefore we still don't understand fully the implications of digital trade. So, but why is it important to study this? So first, we can say that digital is the next step in terms of the economic development. We know that as economies develop, they start from an agricultural society where they trade only agricultural products or natural resources that they have. Then they industrialize and are able to produce some machinery. And then in the end, they have something which is after the industrialization, there is the ongoing term which started in the 20th century, which is the servicization, where banking systems, even IT and all of that stuff has become more and more important in global trade. But our question is, okay, if we start from all of these 3 points, what is next? Is digital the next point in economic development? And if it is, how does it contribute to our economies and where it will lead us to in the end? So one question that we have here is that basically the international inequalities that are happening between countries. So first of all, we know that there are 2 types of international inequalities. These are inequalities that are for economic development from one country to another country. The first one is the inequality between country groups. So how more rich is Austria compared to Portugal or to United Kingdom. And then we have the inequality within country groups, or what is the difference between the Austrian citizens in terms of their income. So when we try to compare international inequality, the slide that I showed before, we had a perfect result of what could be driving those inequalities. So some countries are developed, these are the high income countries, which are very well into that service sector. They're trading services, where the upper middle income countries are most of that are industrialized, or those that are trading in terms of industrial goods. So here we have like China is a typical example. And then when we go towards the ladder of economic development, towards more and lower, we get to the level which are there starting or the still in the process of exporting just natural resources. But then, do we have a certain distinction even between the high-income countries where we have the next level of development? Are those countries which are rooting towards only services that are mainly not as connected to the digital realm? Can we observe some inequalities even there, or do these inequalities just appear because of certain services and not because of the digital involvement in the services? And basically, one of the questions that we want to answer here is, how does the digital economy contribute to the international inequalities? As another motivation, which is, again, very much related to these inequalities, is the trade balances. So we all know that the United States is a country which has a very negative trade balance in terms of merchandise trade. We all know that the war that is happening between China and the US in terms of imports and exports of goods should be now the latest war was the latest conflict was within the electrical cars. Should we import them because our market is stagnating and we are losing the market? But okay, here we have just information about physical goods, and a typical example of a region in the United States that actually does not trade physical goods but is very much involved into digital stuff is California. When we look at the data for California, we could say that, okay, California's yearly exports are much lower compared to their yearly imports. And this is basically because California is a port which imports all of the stuff that is coming from Asia. But we all know that in the end, we have the Silicon Valley, and there are a lot of hubs for digital production, for production of services and goods that are actually marginal and are just traded over the internet. But this statistic is not shown here. So one of the first questions that we want to answer is, okay, if we try to introduce digital stuff, does this change the trade balances of the countries or of the regions? And why is this also why is this also furthermore important is that trade balances actually kind of act as transfers between countries. So usually if you trade, if you export more than you import, this actually improves your GDP or improves your income because you have a net surplus. And if you have a negative trade balance, usually you have a trade deficit, and basically you're giving away your money to someone else, and you're essentially making some kind of a transfer, which is on an international level. And here I have like a comment on GATS mode 3, which is also very much important in terms of trade, but is so far not actually measured. And we will also try to understand how it is improving our knowledge on international inequalities. Basically, GATS mode 3 is the general agreement of trade in services, and mode 3, which is known as presence abroad. Usually, when we say that Netflix exports from Amsterdam, we're saying that those are exports from Amsterdam or from Netherlands. But the mode 3 says that is basically called international presence abroad. So basically, the knowledge that Netflix is producing from selling from Amsterdam in the end goes towards their headquarters, towards the United States. So this is also another transfer of knowledge which happens because of digital trade, because of presence of subsidiaries around the world, but we still don't understand how they act in our international economics. And basically, when we look at trade balances in terms of countries, and we divide the countries in terms of their economic development, we could see a very clear picture. So goods are mainly transferred from developing economies or the upper middle economies towards the high economies. So we could see that actually upper middle economies, on the figure here on your left side, you could see that the upper middle economies have a very high trade balance in terms of goods. So they are exporting more, so they're getting their money, their income a lot from exporting goods, whereas high income countries are those that are importers of this kind of goods. But when we move towards the level of development, and when we look towards services, we actually get transfers which are much more towards developing economies, where the all of the income groups have a net deficit, whereas services are mainly exported from high-income countries, as we should expect. And the question here is, how does this graph look when we try to include digital, or what happens next? Another question that we have here is that we want to study is the twin transition and the unequal phases of economic decoupling. So first, we would like to say, okay, what is economic decoupling? Economic decoupling is the simultaneous growth of the economy, so growth of income, while at the same time is the economy experiences decrease in terms of emission rates. So traditionally, the more you produce, the more you emit, and the higher income you have. So, but over the past 2 decades, we have witnessed the concept of decoupling, which is that many countries, this is especially towards the developed countries, many developed countries actually, I would say, and there are some developing countries that have succeeded in this, have actually transitioned towards economies which are both sustainable on the long run, meaning that they're decoupling their economies and they have economic growth. But another question which arises here is, what is the role of digitization? So the European Union has the policy of the twin transition, which is the simultaneous involvement or simultaneous work towards digitization and towards sustainability, towards reducing the emissions, which is basically the twin transition. But there are only a few studies that have shown like how the twin transition fares around the world. I know that there are several regional studies where they have used patent data and have explored how the twin transition actually reduces or increases the inequalities among the countries. And here we would like to understand whether the twin transition also plays a role among the developed countries, whether the twin transition makes some differences in terms of economic decoupling among the developed countries. And lastly, we have I have been working a lot on is the limitations in economic complexity estimates. So these are estimates that have been used a lot in the literature of economic geography. And they started as a measure in international economics, actually, where they were using countries and their level of productivity in various economic activities to calculate, to predict and explain variations in economic growth, variations in equality, and variations in emission. So basically, the economic complexity estimates were used as some kind of a validation of the economics endogenous growth theory, and it has been used as a way to explain the economic divergence between developed and developing economies, or economies which started at the same point but have evolved towards a different direction. So what is now the state of the art in this literature? So the international data usually uses international trade data, which is measured in terms of goods, and excludes services totally and has no information at all about digital products. And here we actually wanted to say, okay, what is the role of digital products in economic complexity estimates? Do they help further explain variations in growth, inequality, and emissions, and do they even drive some divergence among the countries? And but the main question here is like actually why, if everyone uses digital products all around the world and everyone has an idea of what they are, why we don't have so many good statistics about them, and why cannot we use them to explore those kinds of statistics? So basically, the main issue here is that there are different definitions of what counts as digital trade. And why does this come from? Because mainly it's because there is some confusion in the definition of what is a product and what is a service. In the traditional realm, or in the physical world, all of us very much know like what is a good and what is a service. So if someone makes some clothes, some shirt, we know that that is a good. But if our hairdresser like cuts our hair, we know that that is a service. So basically, when we try to define, when we look in the digital world, we have like a video game, which probably we have bought online or have it on a CD or somewhere. We don't know whether it's a good or a service. When we try to rent Netflix, usually we subscribe just for 1 month or a yearly subscription. And then is this a service or is this a product that I am getting in the end? And basically the main definition is that when we try to look in the physical world, we can easily see a distinction when we try to plot the marginal costs of production of a good or service and the fixed cost. So basically Goods are those stuff that have like a large fixed cost in order to start producing, like we need to create a factory. And then they have a marginal additional cost of producing one more unit. In contrast, services are those that actually have a very low fixed cost. So we can rent a place and I can become a hairdresser by just like small stuff that I need to do my job. But they have a very large marginal cost of serving another unit. And basically this distinction makes the differences in the physical world very clear. So we are able to understand those. But when we try to move towards the digital world, we are kind of like stuck in a point where we have products which have very low or very high fixed costs. So if we try to go to a video store, usually you have that the video store, which is a service, has a high marginal cost and high fixed cost. Whereas when you try to move this towards the digital realm, it starts to look something like a product, which has a very low marginal cost of serving another unit, but it has a high fixed cost to start up. So we need the servers and all of that stuff. And this not clear distinction like leads to several definitions for product-like or productized services, where we have something like payment platforms, video streaming, digital advertising, and even cloud computing. So these are some stuff that was treated as services in the physical world, but now they're moving towards the digital. So their fixed costs remains the same, but their marginal cost reduces. And this would be something which we would call a digital product in our case. And here we have various stuff that appears as a digital product. And actually, when we try to count what counts as a digital trade, there has been a handbook, like the traditional way to calculate or to define digital trade is by, sorry, you cannot see it here from here, is the handbook on measuring digital trade, which is a handbook on measuring digital trade, which is a joint work by the World Trade Organization, by the United States, and sorry, I keep forgetting the IMF. And when they try to define digital trade, so basically they define digital trade as everything which is ordered or delivered digitally. So if I buy socks on Amazon, we would say that is digital trade. But in our case of digital products, it's kind of not the definition that we want. So basically we have something which is digitally ordered, and then this digitally ordered trade can be either physically delivered or digitally delivered. And our definition that we will be using to create a data set of digital trade will count for digital goods, which are in the form of ebooks, software, and video games, and productized services, which are software as a services like cloud computing or online marketplaces, and digital intermediation platforms, which are typical for the stuff like Booking or Kayak, where we try to buy some products on. So basically, this weird definition of everything counts as digital trade has made like, okay, what is the impact of digital products on the economy? Very uncertain or very unknown. And we are trying to provide another definition, which comes from, actually, as we will say, it is a bottom-up definition, and try to provide like how it defines our international economics and how it changes the landscape of economic inequality. So basically what we try to do and to use this definition and our first start was, okay, we try to estimate bilateral trade in digital products as we defined it previously for 197 countries and 31 digital product categories. And we were able to collect data from 2016 to 2021. Like how we did this, we started from bottom data, which includes corporate revenue and data on digital consumption per country. And then we use this data set to study the geography and the implications to inequality of trade in digital products. So how we started, I will speak a little bit about how we started constructing the data set. So we basically try to collect ground truth data about digital corporate revenues and consumption patterns across countries. So we started by using data, we started by Googling and doing on Wikipedia, okay, what are the largest internet companies? And we collected data on more than 3,000 companies, which are the largest companies involved in trade of those kind of 31 digital products categories that we defined previously. And we collected their revenue from Orbis and Statista. And on the one side, we had data on the revenue of the countries, of the firms, and where they were located. For example, we had revenues of Google coming from the United States, Google revenue coming from Ireland subsidiary, and etc. But we didn't know any data about the consumption. Okay, how much Google Cloud is consumed, for example, in the US or in another country. And we actually found a data set, which is an online marketing agency, which is called AppMagic, which collects data on consumption of actually only of just two categories of digital products. Those are the mobile apps and mobile games. And we try to use this data as an input or as a real world available data to train a model for digital products. So basically, our starting point looked like this. So we had known flows from corporate revenue data for example, where are the revenues of Spotify coming from? We have Sweden, which is one of the subsidiaries. Here is Luxembourg, where it's actually Spotify registered. We don't have it on the figure. And we have in the United States, which also has a subsidiary, and etc. Whereas we have the revenues, the known flows from digital consumption data. So we knew the revenues from the Spotify, from the mobile app, but we didn't know the Google Cloud revenues that are actually from cloud computing. So we tried to estimate those by creating a decision tree, which predicts the missing digital consumption patterns in logs, using data where we try to develop a model which is kind of like the well-known gravity model in international trade and in migration, where we use as features GDP, language, history, distance, etc. I have another slide which actually has all of the features that we are using and their data set, but I wouldn't go that much into details of this thing. And a short note on the performance of the model, just so we can be clear about in short about the machine learning. So we estimated our model using group k-fold cross-validation, where we leave 20% of firm category pairs. So basically, we use data when we try to infer data of the revenues of Spotify across countries. We exclude Spotify as we don't use like either all of the data for Spotify is used as training or as test, just because we actually want to extend our data set to new products and to new services and to new firms. And we compared our model basically to linear regression. So first, we can observe that here we have a much smaller mean squared errors in terms of log of USD consumption. And we also did an external validation where we were able to look into the firm's level data set. So for example, certain firms in their annual reports, they have regional data. So for example, we knew what is the Alphabet's revenue share in North America in 2021. And we used our model to see how it is able to explain these regional shares. So we had for several firms data on this. And we again found that our model has a very better performance than a baseline linear regression for now. But I must say that actually one of the things that we are trying to do next is like to improve the machine learning part of our research. But when we try to do some other validations, we again got some good results from here. So then what we had then, so basically we had data on Google's consumption in the US or across 190 countries. But all of this consumption in our model was assigned to the United States, because our dependent variable like defined consumption per firm, not per location of firm or per subsidiary. So basically we use data like only on the headquarters of the firm. And then we needed to assign the revenues towards domestic revenues or towards export. So basically, when we had the data as an example of Google Ireland, so we had the data of Ireland's consumption in total of Google Cloud, and then we try to do two different assignment rules. So first, we try to do an optimal transport assignment where we say, okay, countries trade as little as possible. In this assignment, all of the consumption of Google Cloud of Ireland was first assigned to Ireland, and then whatever is else that's above the consumption of Ireland, of the revenue of Google Ireland counts as trade. So basically, everything that comes from Ireland first is all of the consumption of Google Cloud from Ireland is first assigned as revenue towards Google Ireland, and the rest of the revenues of Google Ireland, here would be the orange part, would be treated as international trade. And then we had another assignment, which we call the headquarters, which we say that, okay, this assignment is relevant for the geography of trade and even for the thing that I said about the GATS mode tree, where we assign all of the revenues of a firm towards their headquarters. So all of the revenue of Google was assigned to all of the consumption of Google that we found was assigned as revenues towards the United States. So we use these two assignments to try to study the geography and the implications of digital trade. And basically, going forward, I will speak mostly about the subsidiaries assignment because we believe that this is much more relevant for fiscal and for tax purposes. But I will also provide some slides with the headquarters assignment results. Okay, so this is actually how our results look. So if we try to do estimates in digital products in USD for 31 categories, and these are the data results for 2021. So basically, if we use the headquarters location assignment, so we get revenues from Alibaba that are in China, and revenues from Amazon that are all in the United States. But if we use the subsidiary assignments, we would say that actually some part of the revenues of or the international trade of Alibaba happens from the Cayman Islands, and some of the international trade of Amazon happens from EU, which is actually Luxembourg. And let's start by analyzing. So in short, I will start by presenting some statistics. So if we try to use we study the trends over the years from 2016 to 2021, we can find that actually digital trade or digital product trade has been growing very rapidly. It grew at an annualized rate of more than 24%. From 2016 to 2021, it grew from 320 billion until around something which is called 960 billion in 2021. And going forward, we will compare our results or study the inequality by comparing digital products with digitally delivered services, which we defined previously as every services that is delivered towards the internet. This could include both like giving a course online and providing that is not counted as a digital product. We will also compare it with the general services trade and with the physical goods trade. So basically, in our data here, what we find out is that digital products trade has been growing much more rapidly than any other form of trade, and that this form of trade continued during the COVID-19 pandemic, which is unlike goods and services trade, whereas we find some similar results for digitally delivered services, but again, we don't find the same trend, which is much larger for digital products. And if we were to study the structure of digital trade, so we would say that in 2021, digital product trade represented around 3.5%, which is not much, but is large section of like, let's say, trading goods, HS section of trading goods. And the most traded digital products were digital advertising, online marketplace, and cloud computing. In digital advertising, we had Google advertising. Online marketplaces would be something like Amazon Marketplace, and then we have cloud computing, which we all know, like Google, Amazon Web Services, and etc. Then now let's study some of the inequalities. So when we study the geography of digital trade, we find that actually digital products exports are much more concentrated when we compare them with the general findings of the trade in digitally delivered services, of just services, and of the physical exports. If we try to draw like the largest exporter of digital products is, if we use the subsidiary assignment, is the United States, followed by the Ireland, and Cayman Islands, and even Luxembourg is one of the bigger exporters. So basically, these are tax havens where actually the headquarters, which act as subsidiaries for the headquarters of many companies. And if we try to draw the Lorentz curve, like we would find that 80% of digital product exports actually originates in only top 3 of the exporter countries, where we compare to a baseline of physical export, which is the least concentrated out of all of them. They originate in around 16% of the exporters. And so if we also study the share by exports by income group, so we could say that actually high income groups or the most developed countries account for a little bit more than 90% of trade in digital products, meaning that actually digital products is even more concentrated towards developed economies compared to digitally delivered services, which is less than 90%, and services in general, in trade and services in general. Next, when we look at digital imports, well, here we find that digital imports are not as concentrated as digital exports. Like the largest importers of digital products would be the United States and China, but China is here an artifact because it actually imports all of the stuff from their subsidiaries. So imports from the Cayman Islands, from Alibaba, from Tencent, and all of the other subsidiaries that are located even in Singapore. And when we try to look at the Lorentz curve, so again, here we find a different picture. So it appears that digital products are the least concentrated out of all kinds of products trade. So actually 80% of digital products import go to around 20% of the importing countries. And when we look at the data set, so when we look at the structure by income groups, so here we would say that upper middle income groups account for much more of importing of digital products. And again, here I would say that this is a result mainly because China is one of the largest importer of digital products. So here we would say that actually while export is distorted towards much more developed economies, the imports are not as much concentrated. But one would say, okay, this result could be driven because trade in digital products encompasses a relatively narrow set. So if we were just to compare to all of the trade in goods or all of the trade in services, we are just accounting for 3.5% of the world trade. So it should be expected to be much more concentrated. So we made an exercise where we compared our results just to the concentration of trade in digital products to trade in just every separate service category, like like finance, ICT, etc., and to a random selection of goods whose actually total trade accounts for the same size as digital products. And again, we found that actually digital products remain much more concentrated in terms of exports. So basically, this is what is driving the trade in international trade in digital exports. It's very much concentrated. And we even tried to look at the network structure. So here we try to compare the digital products network structures with the digital delivered services, with the services and the goods structure. And we again found that digital trade is highly concentrated towards the USA and towards several subsidiaries, which are the countries having subsidiaries of headquarters of many companies, which are basically act as more central nodes. So when we look at the centrality, again, we get that in digital products, the United States centrality of trade in digital products grows much more, and it's much larger compared to the centrality in other forms of services. You have on the top left most of the bar chart there. Whereas as we move towards other forms of services, their centrality goes towards down, and China becomes one of the most central hubs in terms of trade. Okay, we also have some results of digital products exports that find that they're even more concentrated when we look at the headquarters assignment. Then actually only 2 countries account for more than 80% of the exports. These are China and the United States, because most of the headquarters are located towards them, whereas imports remain of similar concentration. And this is the network where we can say that China now becomes much more centered in the digital products trade network when we look at the headquarters assignment. Now let's look at trade balances. So basically, when we look at trade balances, we find that there are only a few countries which actually, when we compare their goods plus services trade balance, so it is the overall trade balance of trade, comparing to the digital products trade balance, we actually find that only a few countries benefit from digital product trade. Sorry, there is like a small typo here. So basically, countries like the United States have a decrease in almost 25% of their world trade deficit because of digital products trade, whereas there are several countries like Ireland which have an increased deficit just because of digital products trade. Whereas when you use the headquarters assignment, then again, the trade balance of the United States becomes much more positive when using just the digital products data, and China again comes up as one of the biggest countries with the largest trade surplus. Sorry. And when we try to compare this towards income groups, so when we use the subsidiaries assignment, we can see that actually high income countries have again a very high trade surplus, like compared to other countries. So we would see that actually that the digital realm is here working in towards the divergence of high income countries compared to other countries, whereas upper middle income appear to be one of the largest importers. But again, when we try to use the headquarters assignment, we can see that their trade deficit becomes smaller just because China we are excluding, and it is one of the upper middle income countries. So maybe not as much. So when we try to include headquarters or the GATS mode 3 into our assignment, we could see that actually the knowledge flows are not as much from developed towards developing, but it might be the other way around. Next, we looked at the twin transitions. So here we grouped countries. We use data only on developed countries, and we try to group them into countries that have decoupled economic growth from emissions. These are the green lines here, and compare them with those that have not decoupled. These are the countries with the red lines here. So what we found actually is that the countries that have decoupled, developed countries that have decoupled growth from emissions, the bottom 25 percentile of the countries export as much digital products as the median country, which has not decoupled emissions from economic growth. So basically, even among developed countries, the twin transition is maybe this is just an indication, it is a correlation, not a causal fact that we are studying here, that may be driven by digital products. So maybe it could be the case that the twin transition and the digital products are making some inequalities even in among the developed countries. Whereas when we look at other exports, they don't appear as related with decoupling as digital products. And well, I forgot to say that we're looking at emissions in two ways. So first, we're looking at production emission. This is what you produce. And then we also do some correction where we use consumption emissions, which is emissions where production emissions that are also corrected for international trade. So here, if I buy a car from Austria and export it to Macedonia, it will be counted as emissions towards Macedonia. And we again find a similar result for both production and for consumption emissions decoupled. But when we look at all countries, we don't find the same picture. So when we look at all countries, we generally find that actually the more you trade is related to decoupling. And maybe we again say, okay, this is probably just because of the level of development. Maybe it's, more developed countries usually trade more. And that's why we get this kind of picture when we use like the whole world in terms of our analysis. And finally, we have the economic complexity. So we do this by adding our data of international trade in digital products to traditional HS4 or data of trade in products, which accounts for around 1,000 products, 1,200. And we calculate the economic complexity index, which is the ECI, the first measure of economic complexity that was introduced. And we found actually that by adding digital product trade, it appears that several countries such as Ireland, the United States, UK, and even Australia have an increased economic complexity, and just because they are much more involved in terms of digital products trade. And this is because digital sectors, the 31 digital sectors that we are using here, are of much higher complexity compared to other digital goods. So it could be the case that this kind of sectors could contribute to their, towards their complexity. And finally, we try to include all of these new measures of new data of international trade into studying how digital product trade economic complexity explains economic growth and emission intensity, which is one of the two most important facts that are used in terms of the economic complexity literature. And basically, in both cases for economic growth and emission intensity, we find that digital products trade has a similar explanatory power as just using only physical trade to explain economic growth and emission intensity. We believe that the reason because of this is actually that economic complexity is something which should be related to long-term growth and long-term structural changes. But here we're using just data on 4 years, and that's why we don't find any significant differences. So in short, to summarize, so digital trade is hard to characterize because of data limitations and basically of different definition what actually counts as digital trade. So here we introduced a method and estimated digital product trade for more than 190 countries and 31 digital product categories. And we actually showed that digital products is growing substantially, and it's actually becoming one of the a large part of international trade. But we also found that it is originated in few places, and digital trade is concentrated enough to redefine some key trade balances, so such as the one of the US and the transfer from the developing towards developed economies. And we also found that actually digital trade performance might be correlated with economic decoupling for developed economies. So there is even a larger difference between developed economies in terms of the twin transition of whether they're using digital products trade or not. And we also found that digital product, that a geography is the digital products shows a compatibility with a geography that is of high complexity. And another question which remains, and we hope to explore somewhere in the future, like 10 years from now using this data, whether they could increase the explanatory power of economic complexity in modeling economic outcomes. So our working paper on this can be found on the archive. And like something for us that's happening right now is that this paper has just been accepted. And hopefully by the end of the month, we'll be able to share the data set publicly of international trade in digital products. And we are also working on extending the data set to 2023. And basically, actually, so what's interesting from my point of view, and I have been very enthusiastic about this, is that actually this data has already been used. For example, Bank of Italia used this data to understand the digital trade of Italy. And there has been a lot of work by this is by the Newcastle University group of Creative Economy Group, where they were using the digital products trade to study the United Kingdom's trade in a global creative economy. So basically, they defined some of the digital product categories as creative categories, and they were using them to explain how UK fares in this kind of trade. And thank you for all of your attention, and that's